This year we celebrate the 30 years anniversary, one of the greatest inventions in the last century, the Internet. No doubt that it was Tim Berners-Lee's concept of web which brings to our lives freedom. However, along with many positive influence to our lives, there are dark sides in the connected world we live in, as the number and virulence of cyber attacks increases every day. We may be often unaware of this, but luckily institutions and scientists all over the world are vigilant and in search for solutions.
NATO project Secure Group Communication in the Quantum Era is running under the NATO Science for Peace and Security program. SPS promotes dialogue and practical cooperation between NATO member states, which are 29 countries, and partner nations, 41 countries, based on scientific research, technological innovation and knowledge exchange. SPS is the oldest continuously running scheme supporting science in the world, started in 1958. NATO recognized very early the role of science for all aspects of our life. Cyber threats to the world's security are becoming more frequent, more complex, more destructive and more coercive. Cyber defense is a core part of collective defense and is one of the key priorities of NATO SPS from 2012. We need to be prepared to defend our networks and operations against the growing sophistication of the cyber threats and attacks.
Secure key establishment protocols are ubiquitous nowadays. They are, for instance, essential building blocks behind the secure modes indicated by the padlock icons we see in web browsers. The security behind these techniques relies on the existence of certain mathematical problems which are hard to crack using today's computers. But what if the future brings about highly improved machines which are much more powerful? What will happen when we face adversaries having access to quantum computing? In our project, we look for solutions tailored for this challenging scenario. We use cryptographic theory to establish structural guarantees at the protocol level and explore performance through implementation on different platforms. Hardness assumptions are chosen to be quantum safe based on coding theory and lattices. To protect the implementation against manipulation at runtime, e.g. through fault induction, we apply runtime verification. To ensure the necessary capabilities are available, ranging from cryptographic theory to advanced software engineering and signal-level analysis for hardware implementations, a team of 4 universities has been formed.
Florida Atlantic University is recognized as a national center of academic excellence in information assurance, cyber defense research. Our team offers the needed expertise in using quantum computers for cryptanalysis. To deploy a group key establishment solution, the specific implementation parameters have to be fixed, such as key sizes and acceptable overhead costs for implementation level protection. The exact choices will depend on the best state-of-the-art attacks and on the theoretical security analysis.
So our team from Slovakia, settled in the Slovak University of Technology in Bratislava, brings many years of experience in the security implementation of cryptographic schemes to the project. In particular, we can help with the detection and prevention of so-called side channel attacks, for instance, based on timing behavior of power consumption of an implementation.
Universidad Rey Juan Carlos is one of the founding members of the Cybersecurity Excellent Network RENIC and is the first Spanish university offering a complete undergraduate program for cybersecurity engineering. Our team takes the lead in the definition of a suitable theoretical security model and in the initial protocol design phase. We have a strong track record in group key establishment, and thus we will ensure that state-of-the-art security models and solutions are leveraged in our construction.
The team from the University of Malta has extensive track record in runtime verification. Once the cryptographic protocol details have been determined, our team will take the lead in specifying and deriving a software implementation offering robust security guarantees against implementation attacks at runtime.
Bringing together expertise from 3 disciplines, computer science, engineering and mathematics, we are certain to achieve 2 goals. First, advancing the state-of-the-art in designing, building and analyzing long-term secure communication systems. Second, training researchers to understand the whole pertinent landscape and being able to manage the complex interplay of cryptographic protocol design with implementation-specific attack mitigation through sophisticated algorithmic and software countermeasures at runtime. Combining all of the above, we anticipate to obtain a full quantum-safe solution for authenticated group key establishment.